Hello, congratulations on making it to the last unit this year. Let's go ahead and get started. We're going to be talking about scatter plots. This is an important concept. You do see this quite a bit on standardized tests, and you'll see it in algebra. By the end of this lesson, you will be able to construct or build a scatter plot and interpret a scatter plot. So let's talk about what a scatter plot is. We've talked about it when we've done like Map Mondays and review, but it's data with two variables or pairs of numerical observations. That's called bivariate data, which is a title of our unit. A scatter plot shows the relationship between the bivariate data graphed as ordered pairs on a coordinate plane. For example, the bivariate data set year and number of visitors can be displayed as a scatter plot. Okay, so construct a scatter plot of the number of viewers who watched new seasons of a certain television show. So you can see that you let the horizontal axis or the x-axis represent the number of seasons. That would be here. We would call that x, and this would be our y, the viewers. So for season one, we have about 32 viewers, 32 million viewers. In season two, we have 26.3. Season 3, 25, Season 4, 24.7, Season 5, 22.6, and Season 6, 22.1. That is a scatter plot. We've graphed the ordered pairs, seasons, and viewers. So like our ordered pair would be 1, 31.7, X, Y, of course. Okay, go ahead and go to the next page. So I want you to construct a scatter plot now. You can do it in your notes. Make sure you show your notes after completing the note check. I'll ask a couple of key questions about it, but I want to see your notes and see your scatter plot. So of the weight of an alligator at various times after hatching. So you want to set it up. You want to make sure you label. Those are your labels. Okay, look at your data. Set up an X and Y and then plot your points, and you will have a scatter plot. Show your teacher. All right, let's talk about associations. We've definitely talked about this when it comes to like map review and map Mondays and things like that. But we have a variable association when it comes to scatter plots. And you have a positive association if the data is trending up as X increases, the Y increases. You could also think of that as like a positive slope type of situation. You have a negative association when as the X increases, the Y decreases. So it's going down like a negative slope sort of thing. No association is sort of like, I kind of call it a hot mess. It's just a bunch of points scattered all over the place, and they really don't have a pattern. That means there's like no correlation. Okay, those are variable associations. Then we can also talk in terms of a linear association, like a line. Okay, so does the data, like this data here, it lies close to a line. Okay, it lies close to the x-axis. In this point here, the data lie in the shape of a curve, kind of like that, so it's not linear. All right, those are your associations that you'll want to remember. Now let's look at a scatter plot and see if we can analyze it. You can analyze the shape of the distribution of a scatter plot to investigate patterns. If the distribution shows a positive or negative association, the distribution can be classified as linear or nonlinear. The scatter plot below shows a positive linear, association. Clusters or outliers can also be identified. Like this is a cluster of data right here. Okay, it's a collection of points that lie close together. This guy is considered an outlier because he's way out off in his own little world, away from all of the rest of the data. Okay, let's look at this and see if you can interpret it. Interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. So consider the different associations that you see. Okay, so we want to see, so for number 2 here, consider the different associations and patterns. The variable association is as the memory goes up, the cost increases. That makes sense. Therefore, the scatter plot shows a positive association. It's kind of going up if you think of it that way. Linear association. The data appears to lie close to a line, so the association is linear. and other patterns. There appears to be a cluster of data. 1 to 2 gigabytes of memory costs between $30 and $75. Your cluster might be like right about here. Okay, there does not appear to be an outlier. It's all kind of clustered together. All right. Let's take a look at these and have you do these in the note check. Interpret the scatter plot of data for the time elapsed and the temperature of water based on the shape of the distribution. Okay, I'm going to be asking you, like, as the time goes up, does the temperature go up or down? Okay, and is it a positive or a negative association? Does it appear to lie close to a line? If it does, the association is linear. And what I mean by that is, like, can you see like a line? If you were to draw a line, would it fall close to a line? Okay, and then are there any clusters or any outliers? Those are the type of questions that you want to be asking yourself. So ask yourself positive versus negative or no correlation. Ask yourself linear or nonlinear. And then clusters, yes or no. And outliers, yes or no. That's what you're looking to find, okay, in both B and C. And I'll be asking you in the note check to identify those things. Okay, let's look at example 3. The table shows public school enrollment from 1999 to 2010. Construct and interpret a scatter plot of the data. If an association exists, make a conjecture guess about the number of students that will be enrolled in the year 2015. So you can see that they've already constructed the data for you in a scatter plot right here, okay? Consider the different associations. As the years go up, the number of students increase. Therefore, it shows a positive association. It appears to lie close to a line, because if you drew a line, it's all relatively close to a line. So it is a linear association. And there's no clusters, no outliers. If you were to think about a conjecture, how many students would there be in 2015? You might draw a point from 15 up to your line, and you might guess that there'd be about 51 million students in 2015. That's how you use scatter plots, is to kind of make projections or conjectures, they say. Okay? Let's have you do a problem to see how you do. Interpret the scatter plot shown for the men's Olympic 100-meter freestyle swim winning times. If an association exists, make a conjecture about the winning time in 2016. So this is 28. What would it be in 2016? It looks like we're 8 years apart on the graph. So you make a conjecture about that. We also want to know, I'm going to want you to be able to say, is there a positive or negative, or none, linear or non, cluster or outliers, okay? And conjecture, make a prediction. Those are the questions that will be in your note check, okay? Make sure that you ask any questions about this if you have any. It's a relatively easy concept, I think, but if you have any questions, please make sure to ask. Bye for now.